What if every meeting you joined was automatically translated in real time, preserving your voice? DeepL just made that a lot more plausible, and it's only one of 3 AI stories worth your attention today. Coming up, DeepL moves from translating words to translating voices and has Zoom and Teams in its sights. Then, IBM releases a benchmark that maps exactly where and why AI agents fail. And finally, a new paper tackles one of the most underrated problems in AI right now: large reasoning models that don't know when they're uncertain. Let's get into it. DeepL has built a strong reputation as the translation tool professionals actually trust over Google Translate, especially for nuance, tone, and European languages. Now it's making a significant move: voice translation. The company says its technology can handle real-time spoken translation and is positioning it directly for integration with meeting platforms like Zoom and Microsoft Teams. This matters because real-time voice translation has historically been a graveyard of overpromised products. The technical bar is high. You need low latency, accurate speech recognition, natural-sounding output, and the ability to preserve speaker intent across languages simultaneously. DeepL is betting its translation quality reputation carries over to voice. The business angle is equally sharp. Enterprise communication tools are desperate for this. Multinational teams lose enormous productivity to language barriers, and clunky subtitle-based workarounds don't cut it in fast-moving meetings. If DeepL can deliver something that actually works at scale, this isn't a niche feature, it's a platform play. The real question is whether their text translation accuracy advantage survives the jump to real-time audio. IBM Research has published a detailed analysis through a benchmark called VAKRA, and it's one of the more honest looks at the current state of AI agents we've seen. VAKRA stress tests agents on reasoning and tool use, the 2 capabilities that are supposed to make agentic AI actually useful, and the failure modes it surfaces are illuminating. Here's what stands out: agents don't just fail randomly, they fail in structured, predictable ways. Reasoning chains break down under multi-step complexity. Tool calls get misapplied when context is ambiguous. And critically, agents often don't recognize when they've failed. They keep going, compounding errors rather than stopping to reassess. This kind of benchmark work is genuinely valuable because the AI industry has a tendency to measure what's easy to measure. VAKRA pushes on the edges where real-world deployment actually lives. If you're building on top of agent frameworks right now, this research is a map of the landmines. The broader takeaway: agents are capable enough to be deployed, but not yet reliable enough to be trusted without oversight. That gap is where most enterprise AI projects are quietly struggling. A new paper on RxE takes aim at a problem that doesn't get enough attention. Large reasoning models, the kind powering tools like OpenAI's O-Series, are often uncertain about their answers, but they don't have a reliable way to communicate that uncertainty. The research applies a technique called conformal prediction to address this. Conformal prediction is a statistical framework that constructs uncertainty sets with rigorous guarantees, meaning it can tell you not just what the model thinks, but how confident you should actually be, with provable bounds. That's different from a model simply outputting a confidence score, which can be poorly calibrated and misleading. Why does this matter practically? Because reasoning models are being deployed in high-stakes domains: legal research, medical decision support, financial analysis. In those contexts, a model that's wrong, but sounds confident, is dangerous. A model that can accurately flag its own uncertainty is genuinely useful. This research is early stage, but it points toward a more trustworthy architecture for LLM deployment. Getting uncertainty quantification right might be one of the most important unsolved problems in making AI systems enterprise-ready. Pull back and look at these 3 stories together, and a clear theme emerges: the gap between AI capability and AI reliability. DeepL is extending a proven capability, text translation, into a harder domain where the failure modes are more visible and the stakes are higher. That's a calculated bet, and it mirrors a pattern we see across the industry. Companies taking what works in controlled conditions and pushing it into messy, real-time environments. IBM's VAKRA research makes that tension explicit. Agents are capable. But capable and reliable are not the same thing. The fact that failures are structured and predictable is actually encouraging. it means they're solvable. But solving them requires the kind of rigorous benchmarking that VAKRA represents, not just vibes-based deployment. And the uncertainty quantification paper is the connective tissue. Whether you're translating voice in a live meeting or running an agent through a multi-step workflow, you need systems that know their own limits. Confidence without calibration is a liability. What we're watching this week is the AI industry growing up in real time, moving from look what it can do to here's how we make it trustworthy enough to actually depend on. That's a harder problem. And it's the right one to be working on. So here's the question I'll leave you with. Which of these reliability problems do you think gets solved first? Agent failure modes, voice translation accuracy, or uncertainty quantification in reasoning models? Drop your take in the comments. And if this kind of sharp, no-hype AI coverage is useful to you, subscribe. We're here every day cutting through the noise so you don't have to.